All right, so how does this work in Java? Most of this is keyed off of one class called socket. So a socket is constructed with an internet address and a port. Okay, an INET address is its own class, which can be constructed with a string or with the pieces of the IP address and so on. But we can also construct a socket with a string. So we can give a string which actually has a host in it, so it could be quote localhost or quote linux.engrcs.com or quote 192.168 blah blah blah, right? And then the port is just an integer. So pretty easy to connect to a remote system. You can basically put the name of the host in here, and it gives you a socket object. And once you have a socket, the two main methods we're going to be concerned with are get output stream, which returns an output stream, and get input stream, which returns an input stream. And our scanner, we normally construct it with system.in, but scanner will take a constructor with an argument of an input stream. So we can make this the result of socket.getInputStream. And printWriter can be constructed with an output stream. So very painless to take a socket, get an output stream, use that to construct a printWriter, and now we have something that we can say printWriter object name dot println, and it'll just shove whatever we print into this end of the socket, this end of the pipeline. And if something on the other end is reading from that socket, say using a scanner, it'll pick up whatever we wrote. So let's do some code. So I'll put a scanner on system.in. I'm going to call that standard in. That's just for reading what the user types. And we're going to type stuff and send it to a server. And we're going to read from the server and display whatever it sends back. So I'm going to connect to localhost, and I'm going to look for a socket on port 1210. And I happen to have a server listening on port 1210 for connections. So that's our secret server. So we want to be able to communicate with this socket. So our input stream is from server. And let's not make it an input stream, let's make it a scanner. It should not. So we'll get an input stream from the socket, we'll use that to construct a scanner, and we'll call that scanner from server, so that's reading from the server. And then we'll have an output device called toServer. So those let us communicate to and from the server. And now we're just going to enter a loop where we read from standard in, take whatever the user types, send it to the server, read a line from the server, print that out, and we'll just loop until the user hits end of file. So while we've got another line coming from standard in, we'll read the next line, put it in a string called text. And then we'll just call the print line method on toServer, and we'll show the text into the socket. And if the server is listening, it should pick it up and do something, and it should send us a response. And we'll pick up that next line from the server and put that back into the same string called text. And we'll print that out. And that'll be our main loop. And when the user hits Control D, which means they're done, we're just going to close the socket. And we'll say goodbye. And that's our main setup. So we need some imports. So we need our scanner. We need our socket. We need print writer. We need input stream. And we need output stream. I think those are the only imports we need. And if we compile this, we're going to get a ton of errors because it wants us to catch all of these possible exceptions. So I could surround each of these calls with a try-catch block. That would be the right thing to do. I could surround the entire set of code with one try-catch block. That would be an incorrect thing to do. Or I can just say my main method is known, possibly throw an exception. That's the really, really lazy thing to do, but that's what I'm going to do here. So now I'm telling the compiler, hey, I know that there are exceptions that can occur in here. And if they occur, just let this generate an exception. Right? So for example, if I try to connect to port, let's say 1214, let's see if this compiles. And I run this, I'm going to get an exception. And it's saying connection refused. I tried to connect to port 1214. There's nothing out there listening to port 1214. So I could handle that more gracefully by putting this inside a try-catch. And then in my catch block, I could check the type of exception, and I could say, you know, port 1214 isn't available. Please select a new port, or one of those other friendly messages. So port 1210, hopefully there's something listening to it. So if I run that, it has connected to the server. And what the server is doing is letting me type in integers, and it's doing nothing. And if I do this long enough, it's eventually going to do something. But what's going on?
You don't have the client class, and you don't have a server class?
Well, I've already got a server sitting out there running. But here's a detail. We've talked a little bit before about buffered output and buffered input, right? So socket communication is inherently expensive. To send one character costs you, I think, hundreds of bytes of transmission. Because we're going out into the network, and this character that I'm sending needs to know where it's going. So it's got destination address, destination port, source address, source port, timestamp, various checksums, all kinds of things. So if you look up the protocol for IP, Internet Protocol, and TCP, Transmission Control Protocol, they define the headers that go around data that you want to send using these things. So basically whatever you're sending goes inside an IP header, and that becomes the data, which gets surrounded by a TCP header, and that gets shoved out, and it's really expensive. So usually these operations are buffered. I say print line text, it's going into a socket, but it's not actually going out on the net. The system is saving it up, and it's waiting until I've got 50,000 bytes to send, and then it's going to go blah, and like puke all of that out in the socket at once. And now a few hundred bytes of overhead for 50,000 bytes of data, it's not a big overhead. But if I want it to send right away, I can force it by doing a flush. So we'll do a flush on the print writer, which will force this to go out immediately. I may have hosed my my server, but let's see. All right, so I send 23 and it sends back 23 times 23 equals 529. So that's what this server is doing. It's taking in integers and it's giving me back the square. So negative 9 times negative 9 is 81. And if you send something that's illegal, it'll just send back a message saying that's not a valid integer. And if I run another client down here that's trying to connect to that server, it's sitting here and it's waiting. Right? Because my server is processing this connection. And when this exits, now it comes back and it says, oh yeah, here's another client trying to connect, and it picks up everything that gets sent and it sends back the responses to those.
Can you open up that code again?
I can.
Reflush.
So down there is the flush. I'll post this on the download area shortly. Okay, so get the basic idea on this client side, right? It's writing with print writer and it's reading from a scanner, but it's going to a remote location. So let's take a look at the server. And the server is really no more complex, except in the very beginning, I do this thing called server socket. So a server socket creates a point to which another process can say, hey, I'd like to connect to that port. So I'm constructing it with one argument, which is a port number. And I'm saying create a socket, bind it to port 1210. Okay, and it's bound to the address of whatever machine I'm running on. And after that, SS equals new server socket, there is a port, a socket with port 1210, and it's waiting for connections. So the server prints out a message saying it's waiting for connections, and then this method accept basically blocks until somebody tries to connect to that port. As soon as somebody connects to that port, this returns a socket, and now we're just off and running. So the picture, so here's my client, here's a server. So we have something called a server socket, and it's got a port number, which you can't see. So we've got a server socket, it's got a port 1210, and the client says, here's a socket. Connect to port 1210. It comes over here, different machine, same machine, doesn't matter. The server socket knows it's listening to port 1210. This creates a new socket, and these two get connected together. And this will have some port number, usually 50,000 something. right? So 1210 is the socket that you can make connection requests to. When this thing says accept, it will see a connection request, create a new socket, and then connect this socket and the client socket together. And now both sides can do the same thing. You can make a print writer, you can make a scanner, or other things. Send into one side, comes out the other, and vice versa. So the server code is almost identical from this point on. It tells me we got a connection, and we'll print out the socket that was created, and then it creates a scanner for reading from the client, creates a print writer for writing to the client, and here it just reads whatever the client sends, tries to parse it as an integer. If it's not a valid integer, it prints out to the socket an error message. Otherwise, it prints out a message, number times number equals number squared. Flushes that out and goes back in loops. And this loop should never exit. Oh, sorry, this loop exits, right, when has next line fails because the client has closed. So we close the scanner and the socket, and then we come back up to the top of our while loop. Right, so that runs forever.
You gotta close your print writer too, right?
I don't think so. Maybe. I don't think it would do any harm.
When I was doing my program, Pt2, it wasn't writing to the file unless I had that print writer dot close. And
Or a flush.
Flush,
So if you flush, it'll force it out. If you close it, it'll force it out.
Oh, okay.
But yeah, it's probably a resource leak if I don't close it, so that's good to have.
It does the same thing where that where the flush is up there a couple lines out.
It does a flush and then it closes basically. But I wouldn't want to close it up here, right, because the connection would go away. But if you want to force it to output without closing it, you can do a flush. And it's like f flush in C. When you write something with print f, it may not actually get sent out.
Poor old C.
Poor old C, we love you.
So you have to do a flush anytime you want output to be sent?
With sockets, yeah, pretty much. Unless you're sending a lot of output, right? Then send all your output, and then when you want to be sure it's sent, go ahead and say flush.
Okay. So if we were doing like a whole tic-tac-toe move, you would wait till the entire decision has been made and then flush that back?
Yeah. Although in reality, if you're not super worried about performance, just flush every time.
Okay.
Right? So if you're working at interactive speeds in particular, it's probably better to just keep saying flush. But if you were transferring a file, right, you would probably just write everything without a flush, let it do its internal buffering, and then at the very end you would either do a flush or close the connection, and that would force everything to go out. But the buffering is there to help performance, right? If you flush, you're deliberately circumventing that mechanism. But if you're not worried about performance, if you're worried about making sure things come out as you write them, then you go ahead and you flush them. So while the server is running, we know we can run the client. Well, we can also say telnet localhost 1210, and that does the same thing. It makes a connection through a socket. That's all that telnet is. It takes a host name and a port number and establishes a connection there. And whatever you type over here gets sent, and whatever is sent from the server comes up and gets displayed in your telnet session. And if I had Putty on here, I could run Putty, connect it to the localhost port 1210, same thing would happen. Whatever you type would get sent to the server, whatever the server sends appears on your screen. So the client side that you're making is sort of like your own version of Putty or telnet, which means if you work on the server side first, you can do some testing using Putty or Minicom or whatever you use for doing I/O, and then you can work on the client side. All right, make some sense?
If so for Pt5, we only need to get two things working, and that's the server So like the second person would be using the server to reply back to the client?
Yeah, so you're gonna have two things running, right? Like two windows, server and client, and you can type over here on the client side and it appears on the server. You can type on the server side, it appears on the client.
Okay.
Right, and it appears each time you hit enter.
So if, like, could we also, if we get past that point and we keep making it better, could we get it to where the server is just a third party that doesn't actually interact?
Mhm.
We have two clients talking to
Yes,
each other?
definitely. So the server can simply manage connections, and your client could say, I want to talk to Pearson, and if Pearson connects and says, I want to talk to Spencer, right, it can put those two sockets together, and then it backs out.
Okay, and
And then you got a full-blown like IRC kind of thing. Or you can make it like a group, right, so everybody talks to everybody, and 10 people can connect to the server, and whatever somebody sends to the server gets broadcast to everybody with a handle in front of it to say who it is, and now you got IRC. And the cool part is,
Pretty soon you have Facebook.
yeah, right, right. This is trivial, right? I mean, think about what's going on in here, and there's almost no code here, right? The whole body of the loop is just this one while loop. So I mean, this is really object-y, right? Need a better word for that. But it's really plying off the whole idea of objects. Because we got print writers, we got scanners, we got sockets, we've got server sockets on the server side, right? And they come with all this machinery inside, and we're just using that. We're using the get input stream method on a socket to construct a scanner, and we're using the has next line method of the scanner to read lines from the socket. And it's really just sort of putting the pieces together. It's like playing with Legos, right? You don't have to build a block that does something. You just take one out of your box and you put it on the piece you want it on top of, and you put something else on top of that. That's really what's going on here. And doing this kind of stuff in C is really, really tedious, right? You got to do so much of the stuff by hand. Doing it in assembly language is a whole nother layer of adventure, right? Doing it in Java, it's like, this is what I want to do, and I basically write a line or two of code for each thing I want to do, right? So it's a very nice mapping. So this really kind of like plies off that mindset of objects having all of this machinery that goes along with them, and then just sort of building on top of that. All right, so so we talked about this, right? You're going to need a pair of threads on each side. One to send, one to receive. This is what we call full duplex. Half duplex, you send, this other side sends, you send, the other side sends, and so on. Full duplex, you can be sending and receiving simultaneously. Okay, that's what we're after. That's sort of the model we're used to.
And does that mean you need two different classes for each client and the server, so you can have two different?
Probably, yeah. So the client's probably going to have a send thread and a receive thread, and the server will have a send and receive.
And those have to be in different classes?
Those probably, yeah, send class and receive class that you like start as a, make those extensions of threads, and then you use the start method. Exactly. All right, so the client side here, I'm connecting to localhost. I could make that an actual IP address. And if your server code's running on another machine, right, this will just work. The trick is, if you try to do this through Clark's network, it doesn't work. Okay? Because there's firewalls and policies and all kinds of things that ruin the fun. But if you were on your home network, right, where you've got a router and you've got different machines connected to that router, each machine gets its own IP address. Typically, it's 192.168.0 dot something, or maybe 1 dot something, right? And if you put in that IP address of another machine and it's running the server code, this will work. You got one machine here, and you're typing here, and it's coming out there, and vice versa. which is pretty cool. So what I'm going to do is in the collaboratorium, I'm going to put a router in there, and I'm going to put a switch box on it to turn it on and off. So if you want to experiment with this, you can go in the collaboratorium, turn the power onto the router, wait for it to boot up, and then connect your machine to that router. So there's going to be broadcasting a CSE 223.
Is that what that was?
That's what that is, yeah. So it's going to be an SSID of CSE 223. And it's secure, so it has a super secret password, which is password 223. So you gotta put that in. And once you do that, you won't have an internet connection anymore. Okay, you won't be connected to Clark. You'll be connected to this router, which doesn't go anywhere. Okay, it's not on the net. So if you try to get a man page or a web page or something, right, it's not gonna work. But if you have two machines connected to this, they can talk to each other. So if you want to develop this on a single machine, that's great. And then once you've got that working, you can experiment with connecting them to each other through a router. And then you can go out of your box and get to another box, which is pretty cool. So I've got the power dialed down on that router. So hopefully it doesn't interfere with anything, but we'll see. IT blamed it for the Wi-Fi problems in the building. Because I used to have it in the back room over here. And they said, we found out what's wrong with the Wi-Fi. It's a rogue router in room 155. It's like, no, we put that there because of the Wi-Fi problems. So.
It's also why it's so hot in here.
Yeah, yeah.
Oh,
That's possible because it's a really old router, so it might run really hot. All right, so questions about this? This is kind of a crash course on networking on Java. But this is really all there is to it. It's two classes, socket and server socket. And the difference is server socket creates something bound to a port. Socket just creates a socket that's unbound, but you can say connect to this port. And then you can start talking back and forth. And there's other ways to do this besides a scanner and a print writer. There's a lot of different versions of I/O, and we might go through some of these next week. There's buffered writers and readers. There's input streams and output streams, and input writers and output writers, and all kinds of other things. And there's huge sections of Java doc devoted to I/O. But scanners and print writers will get you there. Okay, it's not efficient, but it'll work. And so I'm concentrating on those in here. But there's other methods we can use, and in particular, if you want to do a lot of binary I/O, there's better ways to do it, right? So if you're not trying to make things pretty, like print a double and have it come out as a bunch of digits, right? If you want to just send raw binary data, there's ways to do that. And so we're sending messages between these programs, but we could be sending, the contents of executable files or images or movies or something like that. And it doesn't really care what you're sending, it's just bits. When we read from a socket, we're just getting bits, and we can do with it whatever we want.
Probably shouldn't send movies.
You could.
Start flexing in school.
So you can send War and Peace pretty easily, right? So we could do that.
Jesse's favorite.
Use what's it called, Wonka Vision? You send it to
Oh, yeah,
bit by bit. No, I was talking about those in Minecraft stuff. I don't know. It is.
Display all 159 possibilities.
I don't have War and Peace handy.
There's 199 possible flavors.
Yeah, we don't want to send the WAV file. Maybe I don't go.
2015 coming in clutch.
What was I doing with War and Peace in 224? There we go.
Yeah, I thought we used War and Peace in 224.
We used it every quarter,
Really?
but
I've never read it either.
My stepmom has read it for some reason.
Really?
Error.
So yeah, we can send it to our server, and it doesn't seem to have any integers in it. So
Is that standard?
I was telling her about trying to break my code, and she's, I was like, this big file of War and Peace or whatever, and she's like, oh yeah, I read that one.
Really?
Why?
cool. Ask her how it ends, and we don't have to read it.
You should ask her if the word list was correct.
Right. How many times?
The 2,742nd word is that.
All right, so don't run this on the server, okay? Because if you run this on the server, only one person will be able to access that port. Because when you bind a socket to a port, nobody else can bind to that port, right? Because when you connect to a port, you got to know where you're connecting to. So only one thing can bind to a particular port. So if you happen to do this on the server and somebody else tries it, right, it won't work for one of you. So do this on your own machine if you want to be sure that it works. What else can I tell you? Yeah.
So the bare minimum doesn't need threads, but if we want to do multiple, we probably.
No, you do need threads for the bare minimum because you want full duplex communication. So you want to be able to be typing over here, and while you're typing, if someone hits enter on the server side, it should appear immediately, right? And that's only going to happen if it's threaded.
Because then you could just use the code that he just showed.
Yeah, so you can do denial of service attacks on whoever you're testing this with. But they probably won't test it for you for long. So yeah, suggestions, start with the server side maybe, because you already have Putty as a client, right? And play around with this, right? Make yourself an echo that just receives something and sends it back. And make that into a server, and now you can use Putty to talk to it, and whatever you type in, hit enter, it should send it back to you. Or send it back in reverse or something like that. And that'll get you going with the idea of ports and the idea of sockets and all the details of setting up an input stream and an output stream. And then it's just kind of doing the same thing on the client side, and then it's figuring out the multi-threading, and then probably the shutdown mechanism is the last piece. And if you finish that quickly, then you can start embellishing and having fun, make a GUI.
So Putty is like a GUI for what our, like a more complicated version of what our server class does? Or?
Yeah, Putty is basically, it lets you send and receive to and from a socket. And when you run Putty, right, it normally defaults to SSHD, but you can say do a raw connection, you can put in a port number, and then it's just sending stuff to a socket. That port number is, you know, the port number of a socket.
You still use localhost? Is that like a keyword for?
Localhost means 127.0.0.1, so it's kind of like the IP address of your machine. If you knew what your actual IP address was on whatever network you're on, you could type that in and that would work also. But again, on Clark's network, it's kind of funky, just because there's firewalls in the way. Yeah?
I was just wondering if you connected to port 22 with our client code or whatever, would it encrypt it for you?
That's a good question. So let's do that. And it's not as satisfying as you'd hope. So I got a connection refused.
What are you trying to connect to?
port 22. So I can't do that because I don't have an SSHD running, SSHD daemon running on here. But let's hop onto the server. So this will connect to 22 because there is a SSH daemon running on linuxengrcs.com. But as soon as I try to send it something, well, it's trying to talk to me. It sent me a header, told me what system it's running, and this is using OpenSSH. Protocol mismatch, and then it gave up. So we can telnet, well, it's just sending whatever we type, so I don't know what the SSH protocol is.
There's no way to figure that out.
Nope, that wasn't it. But if you knew what the SSH protocol was, right, and it was typable characters, which I don't think it is for long, you could establish an SSH session like this. And then you'd be encrypting stuff in your head to send it. On the other hand, if I try to put up a server on port 22, right, that's going to give me a permission denied. So ports less than 1024 are privileged. You have to be root to be able to bind to them. Anything above 1024 or higher, you can bind to as long as it's not in use. But those first 1024 are reserved. Now if I sudo this, right, it should bind to it. And now if someone were to try to SSH into this box, they'd suddenly be talking to this server, right? And you don't want to do that in general because, right, you've defeated the SSH. If I tried to do that on a Linux server, it would fail because 22 is already in use. So let's put that back. All right, so that's waiting for a connection. And if I try to run this again, it'll say that's already in use.
What does and mean?
Throws in the background.
Oh.
So now that's sitting in the background. So I can foreground it and kill it.
It is. Why have to kill? Why can't you put and in it?
Yeah. Send to the happy place. Yeah.
That's true. Maybe I should do that.
So other questions?
When it's ready.
You think you can make sense of this? All right, let's talk Lab 5 really quickly. So who's looked at Lab 5? The brave. So Lab 5, you're doing networking between Raspberry Pis, but you're on the other end of the spectrum. We have no sockets, we have no server sockets. We're doing this barehanded, okay? And you're doing this with 3 wires. So you're building your own network protocol. So your 3 wires are a ground line, connections between pin 16 and pin 18. And with 3 wires, you have the following. You have ground. You have a line that we're going to consider to be the clock, and we have a line that we consider to be data. So we've got 2 Raspberry Pis, and we can kind of think of it as like a client and a server, but it's not really that sophisticated. we know how to toggle the output of a pin, make it 5 volts or make it 0, right? That's how you turned LEDs on and off. We know how to read the voltage level from a pin, that's how you read the switch. So one of these sides is going to drive the clock.
Can you switch to display?
Oh yeah, good idea. One of these sides is going to drive the clock by pulsing it high and low, and it's going to drive the data line by pulsing it high and low. So it's transmitting. The other side is reading the clock line and reading the data line. And by controlling the clock and data, the client's going to be able to send bits to the server. And if you can send a bit, you can send 8 bits, which means you can send a character, and if you can send a character, you can send words and sentences. So we're making a one-directional chat program. You can type on the client Raspberry Pi, and it'll get printed out on the server Pi. And they're connected, not through Wi-Fi, but through 3 pieces of wire, because there's no Wi-Fi in these Pis. So you run connections between pins 4, 16, and 18, I think. So we need a way to say I want to send a 1 or I want to send a 0. So we have a really simple protocol. So here's the protocol. If you want to send a 0, we set the data line low. We raise the clock line, leave it high for a little bit, send it back to low. That's how we send a 0. If you want to send a 1, raise the data line to a 1. Once it's high, raise the clock line, drop the clock line. That sends a 1. So on the server side, what you do is you monitor the clock line. You just go in a loop and you just keep reading the clock line. If it's 0, keep reading it. At the point where the clock changes from a 0 to a 1, you sample the data line. If it's low, you just read a 0. If it's high, you just read a 1. And then you just go back and wait for the falling edge, and then go back to the top of your loop. So you only read 1 data bit while the clock's high, and you try to read it as close to this rising edge as possible. Now, one problem is you're sitting in a loop on the receive side. You may not actually read the clock line just as it's going high. You might not read it till a little bit later. So you got to make this clock edge big enough, this clock pulse big enough, that you know the server is going to have time to read it. If you just bump it up and pull it back down low a nanosecond later, you're probably going to miss it over on the server side. So set the data line, raise the clock, wait a little period, drop the clock. Put out the next data bit, raise the clock, wait, drop it, keep going. On the server side, monitor the clock. When you first notice it's high, read the data value. That's a bit you received. When you receive 8 bits, treat that as a character. First bit you receive is the least significant bit. So when you start receiving, start building up 8 bits, lowest bit to highest. Once you've got 8 bits, that's a character, print it out. Go back to the beginning of your loop, get the next character. That's the essence of Lab 5. And Lab 5 is optional. Okay, so 50 bonus points if you tackle this. So the clock line is normally low, data line is set high or low, and then the clock line is pulsed. ASCII characters are sent as 8 bits, least significant bit first. We don't have time to talk about the sync pulse, but we'll talk about it Monday. Sync pulse is how you deal with the possibility that you might get out of sync. You might think you're waiting for the 3rd bit, but because you missed a bit, you're actually waiting for the 4th bit. And now you think you're getting the letter A, but you're going to get some weird character instead, right? So the sync pulse is a way to sort of reset both sides and say, okay, now we're at the beginning of a character. The next bit you get, that's the least significant bit. And the sync pulse is just a special handling of the data and clock lines. So we can talk about that on Monday, but you can get the bulk of this coded up without that. So you get to work in groups on this. Okay, so 2 groups. Do I say that in here? Yeah, you need to work in groups of 2, TWO, I know how to spell, 2 groups. And so you're going to take your Pis, connect them with wires, type on the client side, should print out on the server side. It's a fun thing to get working. And it's so much harder than doing it in Java. It's part of why it's fun. Okay, so you're going to do it in Java, but you're not going to have access to the socket class and all of that stuff. All you have is set a line high, set a line low, or read a line. see if it's high or low. So you're kind of doing the whole TCP/IP stack yourself, but it's not TCP/IP. It's actually something called SPI, basically, Serial Protocol Interface. Yeah.
So it has to be two groups of two?
Well, you need 2 pies.
Okay.
So yeah, find another group.
3 groups? That's okay.
Say again?
Like 6 people total?
Yeah. So whatever you have in your group and somebody else has in your group, you're working on it together. But you're turning this in, right, for your group, and the other group will turn it in for them.
Okay.
So, but you'll be demonstrating it together. All right. So I will see you.